Each day, millions of gallons of gasoline and other fuels are transported by highway. Almost every community has at least one gas station, and tank trucks are the common method of resupplying these stations. The U.S. Department of Transportation regulates the design and manufacture of fuel tank trucks in the United States. The required safety features make transporting flammable and combustible liquids as safe as possible. Accidents do happen, however, so you need to know what to expect and what to do if a fuel tank truck is involved in an incident in your jurisdiction. In this program, we will closely examine low-pressure fuel tank trucks. We will, 1, describe the structure and safety features of fuel tank trucks. 2, present the 4 types of incidents that can occur. 3, demonstrate basic procedures for controlling leaks in low-pressure fuel tank trucks. And 4, show safety rules for responding to incidents involving fuel tank trucks. Knowing the structural and safety features of fuel tank trucks makes you better prepared for an emergency involving these trucks. The most common tank truck for transporting low-pressure fuels, such as gasoline and diesel, is known by its DOT designation, the Motor Carrier Number 306, commonly called an MC306. The information in this program will focus on the MC306. Let's look at the structural features of this vehicle. The MC306 is designed to carry low-pressure liquids, including flammables, combustibles, and Class B poisons. The cargo must have a vapor pressure of under 3 pounds per square inch. Not all liquids carried by the MC306 are hazardous, however. The MC306 is made up of an elliptical tank resting on a chassis or trailer. Different types of materials can be used to construct MC306 tank trucks. These materials include mild steel, abbreviated as MS, high-strength low-alloy steel, abbreviated as MSLA, stainless steel, abbreviated as SS, and aluminum alloy, abbreviated as AL. The most common tank material is aluminum, which is relatively strong and lightweight. To determine the type of material used for the tank, you can look at the DOT-required metal certification plate. The metal plate will be located on either the left or right side near the front of the tank. The abbreviation of the material used in the head, shell, weld, and lining appears on this plate. If you know the type of tank material, you will have a better idea of how the tank may behave in an emergency situation. For instance, aluminum tanks will often melt in a fire situation. The melting point of aluminum is only 1200 degrees Fahrenheit. If the vapor space area of the tank is impinged by fire and it melts, it will expose the entire cargo. Fuel tank trucks often have segmented separate compartments to transport different types of fuels in the same load. The compartments are often not the same size. Generally, the front and rear compartments are the largest. The compartments are created by the addition of dish-shaped bulkheads. The shape of the internal bulkheads is similar to the tank end. There are usually baffles within the compartments that keep the product from surging during transport. The baffles also add strength to the shell of the tank. The number of baffles needed is determined by the capacity of the compartment. When the truck is filled, a minimum of 3% of the capacity of each compartment must be left empty as a vapor space to allow for product expansion. A compartment of 2,500 gallons or more will have a manhole that measures at least 11 by 15 inches. Most compartments are less than 2,500 gallons, however. These smaller compartments have round dome covers on top. The number of manholes or dome covers does not always determine the number of compartments, however. Some very large compartments are fitted with 2 manholes. Count the number of discharge valves to determine the number of compartments. The number of compartments and the capacity of each one can also be found on the DOT metal plate. There are 4 types of safety features on the MC306: pressure relief devices, shut-off valves, overturn protection, and valve protection devices. Both normal and emergency pressure relief protection is required on MC306s. These relief devices are usually a part of the dome cover assembly. The dome cover vent has a safety mechanism that prevents it from opening completely and causing a large spill in the event of a rollover. The relief devices in the dome covers must be mounted so that water cannot accumulate around them, which would make them inoperable in freezing temperatures. Shut-off valves are important safety features of the MC306 because they help prevent large-scale spills in the event of an accident or fire. The shut-off valves will be located inside the tank and also outside the tank at the intake and discharge pipe connections. The primary operating mechanisms for the shut-off valves are located at the intake and discharge connections. The shut-off valves must also have a secondary control that can be used in an emergency if you cannot access the primary controls at the discharge connections. The secondary control is usually located on the left front end of the tank. The secondary control will close any open valves by either an air-activated, hydraulic, or mechanical system. Near the secondary control, you will also find a heat-sensitive fusible element that activates the shut-off valves at a set temperature less than 250 degrees Fahrenheit. At least one additional fusible element is mounted on the underside of the tank to activate the shut-off valves in the event of fire under the vehicle. Overturn protection is designed to minimize damage to the dome covers and the tank in the event of a rollover. Overturn protection devices include overturn rails or guards that protect the manholes, dome covers, and emergency venting devices in the event of a rollover. These rails are designed to withstand a vertical load of 2 times the weight of the loaded truck and a horizontal load of 1/2 of the loaded truck weight. Valve protection devices protect the valves against mechanical damage in the event of an accident or other emergency. Valve protection is provided by a shear section on each discharge pipe that will break under strain, leaving the emergency valve seat and valve head intact. There are 4 types of incidents involving fuel tank trucks: a spill without ignition of the product, a spill with ignition, an overturned vehicle, and a fire in a truck part, such as a tire or brake pad. In each of these instances, first, assess if there are victims that can be rescued. Avoid futile rescue attempts, however. Next, begin to verify product type and find out approximately how much product is on board. Always secure the area immediately. Determine if evacuation is necessary. In an incident without ignition, remove all ignition sources immediately. The truck's battery can be a source of ignition. To disconnect the battery, look for the external battery disconnect switch. If there isn't a switch, you may have to disconnect the battery cables. Be sure to disconnect the negative cable first to avoid causing a spark. If you have the correct personal protective equipment for the product involved, attempt to control the spill. Confine the spill by diking or diverting the product to a retention area. Reduce the possibility of ignition by reducing the amount of vapor. Cover the spill with the appropriate type of foam or other vapor suppressant product. If it is possible to stop or slow the leak, begin plugging and patching. Call the carrier or cargo owner. They will need to contact a cleanup crew to dispose of the spilled product and to clean up any environmental damage. In an incident that includes a spill with ignition, first, assess if there are live victims that can be rescued. Don't attempt futile rescue or recovery efforts that may result in further loss of life. Next, secure the area. Protect exposures and initiate control operations. If the fire is being fueled by the product from the intake or discharge piping, activate the shutoff valves using the secondary controls if possible. If a fuel tank truck is overturned, but there is no spill or ignition, the cargo must be offloaded before attempting to right the vehicle. Offloading and righting an overturned tank truck should only be done by specially trained personnel. Call the carrier or cargo owner immediately for assistance. In an incident involving a tire or brake pad fire that impinges on the tank, cool the tank before you attempt to extinguish the fire. Cooling stream should be applied at the point of impingement to keep the aluminum cool so it will not melt. Another cooling stream applied at the top of the tank will help reduce pressure inside the tank. The basic procedures for controlling tank truck leaks require that you wear proper personal protective equipment and that you are trained in hazardous materials response. There are two types of leaks in low-pressure fuel tank trucks: tank shell leaks and pipe, valve, cap, and fitting leaks. For tank shell leaks, you should attempt to patch holes that are below the liquid level first. Holes that are above the liquid level will leak vapors and should be patched later, but the liquid leaks are urgent. For very small tank leaks, it may be possible to just catch the leaking product in a container rather than attempt to patch the hole. To patch holes or tears at the weld seams or at metal creases, try small wood pieces or lead wool. For larger holes, wooden or neoprene wedges or plugs may work. Leaks rarely occur in pipe walls unless they are weakened by fire. Other small leaks may be due to stress or corrosion of the pipe. Whenever you have a leaking pipe, valve, or fitting, use the emergency shutoffs before attempting to contain the leak. A dripping leak can be slowed or even stopped by applying duct tape. You can also use a leak sealing putty-like material. Catch any drips with a container placed under the leak. In leaks around valves and caps, look for shutdown instructions near the valves. Closing valves above and below the leak can sometimes solve the problem. Remember that generally, butterfly and ball valves are closed when the operating handle is not in line with the pipe. Caps on tank truck piping are generally groove and latch or cam locks. If you have doubts about how a leaking valve or cap works, pull back and wait for assistance. Making an error could result in a small leak becoming a major spill very quickly. There are many safety rules for working an incident that involves fuel tank trucks. The potentially destructive power of the product makes safety a critical factor. As with all hazardous materials incidents, you must identify the product before you proceed. Verify that placards are correct for the current cargo by checking with the operator or shipping papers. Sometimes placards are not changed when the truck changes products. Fuel tank trucks are required to display a product placard after they are empty until they are purged clean. Keep in mind that the vapors of an empty tank truck are extremely dangerous. For instance, in the case of gasoline, it is not the liquid, but the vapors that are highly flammable and potentially explosive. Fuel tank trucks are not required to have gauging instruments to indicate the amount of product on board. Once again, check with the driver or the shipping papers. Always secure the scene of any incident involving a fuel tank truck. Because these incidents usually occur on highways or other public right-of-ways, they quickly draw the attention of spectators and the media. The public often does not understand the possible escalation of the problem. When responding to a call involving ignition, evaluate your foam and water resources. It takes an adequate foam application rate and a consistent high-volume water supply to fight a fire in a fully loaded fuel tank truck. Be prepared for a possible decision to let it burn until the fuel supply is diminished to the point that full extinguishment is possible. An aggressive attack is not always the best decision. Sometimes just protecting exposures is the correct initial response. When using foam to eliminate vapors and avoid ignition, maintain the integrity of the foam blanket. Direct water streams away from the foam and avoid walking through the foam cover as much as possible. If the tank truck is overturned, You will need to wait for technical assistance to offload and right the vehicle. Use this time to thoroughly secure the scene and remove all ignition sources. To control static electricity charges during offloading, the tank truck must be bonded and grounded. Bonding means to use a conductor to connect two or more electrically conductive objects together. Grounding is a means to connect a conductive object to the ground so the electricity is released into the earth. In an overturned situation, bonding can be achieved by attaching a cable from the overturned tank truck to the offload vehicle. To ground the vehicles, the offloading crew should attach grounding cables to the tank truck and, following a path that does not allow the cables to come into contact with other energy sources, attach the other end to a metal guardrail post or other metal conductive pole or post that is buried in the ground. One safety step that you can take before an incident occurs is to know before you go. Examine an MC306 tank truck in your area. Learn where the shutoff valves and controls are and how they operate. Also know who you can call on in the event of an incident involving a fuel tank truck. Keep mutual aid agreements and technical assistance rosters up to date. If an incident occurred in your jurisdiction tomorrow, could you quickly access enough foam? Do you know of a spill recovery team in your area that could clean up a 5,000-gallon gasoline spill? Are you aware of a local heavy towing service that can properly right an overturned tank truck? These are a few of the questions that need to be answered before the call comes. In this program, you have seen the structure and safety features of MC306 fuel tank trucks. You have seen the 4 types of incidents that can occur with these trucks. You have seen demonstrations of basic leak control procedures. And you have seen safety rules for responding to incidents involving fuel tank trucks. The MC306 is a common sight on most highways and community roads throughout North America. It is built to be safe and reliable, but accidents do happen. Take the time to prepare for a possible incident in your jurisdiction. Take the time to closely examine a fuel tank truck. Take the time to determine what you may need and who can be called. Consider the potential disaster posed by 9,000 gallons of gasoline in an overturned truck in your community's busiest intersection. Right now, take time to consider what you may be up against and determine what you can do to be prepared.